Welcome to Tech Talk. My name is Benjamin Obeta. Today in this video, I'll be discussing what is pseudocode and what is flowchart and how they are used to simplify the process of writing computer programs. What is pseudocode? Pseudocode is just a representation of a program or an algorithm. It's just step by step way you write out how your code is going to work, how the program or algorithm the steps is going to take. That's just what pseudocode is. It is used to express the idea and logic behind a program. Why do we use pseudocode? Why pseudocode? So pseudocode is used to simplify the process of writing computer programs. So it helps to break down complex algorithms into smaller pieces. It also allows programmers to express their ideas and logic before actually writing out the code and making it easier to catch mistakes and identify bugs where necessary or identify a breaking point in that program. For example, we are given an algorithm to write a program that calculates the average of three numbers. So given a three number, we want to calculate the average. So if you are to write this algorithm, like to write down the steps of which you are going to take in order to write this algorithm that will solve the average of three numbers. Then what is the first step? To impute the first number. Since we are dealing with three numbers, you have to input the first number, then we input the second number, then we input the third number. These are the steps. So the next step is to add those numbers, add the three numbers together. The fourth step is divide the sum by 3 to get the average. Then you output the average. Then you end. That's the end of the program. This basically example of pseudocode, it applies to other programs. So any solution that you can think of is just the step by step of actualizing that solution. Right now we're going to jump into flowchart. So what is flowchart? A flowchart is just a graphical representation of an algorithm or process. It uses symbols and arrows to show the flow of the program, making it easy to understand and follow. So since a pseudocode is step-by-step representation whereby you write down the steps. So flowchart is graphical representation of those steps we have written down. So here now use blocks, graphics to represent the process, the input, the output, the summation, and the rest of it. As I said earlier, flowchart uses symbols and diagrams and with lines to describe the flow of the program. So in flowchart, basically, we use this symbol over here as the starting point and the ending point. So when you want to start a program or the ending, that's where you use this symbol. You have another symbol called the process, a rectangle shape. So this rectangle shape is used for process. For example, you want to say 2 plus 2 or A times A or any process. That's what you use this rectangular shape for. We have another shape which is this can be used as an alternative to rectangular shape. This is an alternative to this rectangular shape. They are all used for processes. So another shape is the input and output shape. This is for the input and output. So for example, you want to key in to a system. For example, you want to enter numbers, you want to enter characters. This is what you use to indicate that it is an input, and also it is used for output also. So for example, you want to print out something in a console, this is what you use as the output. Another important shape we frequently use is the decision. This is called the decision shape. So this is used for decide, for example, uh, conditions. For example, we have if statements, do while loops. So this is used to make decision. The off page, for example, you are drawing um, a flowchart and it does not contain on this particular page. You can use this to show that there is a next page. It is actually this is the page down and this is the page up. So these are the major shapes we use in flowchart, and frequently you'll be using these shapes to indicate the flow of your program. So if you have other shapes here, you can explore that by reading about them and practicing on them. So yeah, with this, let's solve the example. I want to use an ALX assignment to demonstrate how we can use flowchart to solve algorithms. So this, I want to open my page on ALX and navigate to the project. So I want to use this one of the project in ALX to demonstrate how you can use a flowchart to solve algorithms. Okay, let me use this one. Here it said develop an algorithm calculates a running sum. So say a user will enter a number that will be added to the sum, and when a negative number is encountered, then you stop adding the number and write out the final answer. So though these are flowcharts, and I will paste it somewhere here, so you can easily yeah. So saying that I will remove all this, so we start drawing our flowchart. So that's the first step is to start. You draw our starting points. These are our starting points. This shape for start. You can add text by clicking on the text here, and we write. So we start by bringing the starting points. Then the next step is initialize the sum, which is a process. We drag the process to this point and to connect. So we can label it and say initialize sum is equals to 0. So the next step is input numbers. So we'll be needing to input number. What is the input? Look at the input here. We drag an input box to this, and we can label it enter number. So that number can increase it to be in line. Yes. Then the next step is to check if the input number is negative or positive. So here is decision. You are checking, you want to check. So what do you need here is decision. You need to make a decision if is negative or positive. Then we drag our decision symbol to this, and you can see. So we check if the number is positive or negative. How do you know a number is positive or negative? So any number that is less than 0 is negative, while any number is greater than 0 is what? Positive. So you can say if number then okay, if input number, let's say input number, if it is less than 0, then if it is less than 0, then that is a negative number, and if it is greater than 0, that's a positive number. So, and from this what you are required to do from the algorithm, say that, let's go back to the algorithm. Yeah, the user will enter a number that will be added to the sum, and when a negative number is encountered, stop adding the number, then write out the final result. So when a negative number is encountered, you start adding the number, and when it is not a negative number, you continue to add the number. So adding the number is a process. So we drag a process over here. So connect it over here. This is a process. This is where you're going to be using to add up the sum. So if it is not, if it is greater than 0, if it is greater than 0, we'll be adding up the sum here. So sum will be equal to sum plus the number, the input number. Sum plus the input number. So, and this is going to be repeating. So we add a line showing that this will be repeating itself until a number that is less than a number that is negative number is entered. So we connect, yes, connect it here to this place, meaning that at this point, if the number is not yet negative, it will add up, it will sum up the number, to add the number to the sum, and return to this point and repeat again until a user enters a negative number. So we have here, say so is it, so it's not a negative number, no, to branch here, but if it is yes, to go down here. So next, if it is yes, so we have to print out, that is output, print out the output. So if it's a negative number, we print out the output. So we say print out the sum. Then, and that's the end. You end your program. So you end the program. Say end. So guys, we are done. We are done with the flowchart. Yes, let's repeat again. First of all, we are following the pseudocode over here to solve this algorithm. So we start drawing our start symbol. After that, we initialize the sum, which is a process. We draw the process symbol. Then we enter a number, which is an input. We draw the input symbol over here. Then after that, we check if the number is positive or negative. We draw the decision. This is used to check if it is negative or positive. So if the input number is less than 0, that is, it is negative. It will print out the sum. But if the input number is greater than 0, it will sum up the number. It will add the number to the sum and repeat itself. So yeah, that's all that, guys, and this solves the problem, this algorithm. John, I will say that both pseudocode and flowchart are essential tools for programming language for programmers. They help to simplify the process of writing computer programs and make it easy to understand and follow the logic behind the code. So yeah, it's very essential you understand pseudocode and flowchart. It will make you it will help you to break down complex algorithm into simpler units that will be easy for you to translate into the actual code in any language of your choice.